Welcome to Catscast, a bi-weekly podcast delivering interviews, arts, culture, and history from New York's Catskill Mountains. In this episode, we speak with forest historian Michael Kudish about Catskill's trees and forests following Route 214 between Greene and Ulster counties. Then a phone call with forest entomologist Mark Whitmore on the latest threat to our hemlocks. This episode is sponsored by the Greene County Watershed Assistance Program, helping the public navigate the maze of challenges and opportunities that exist living and working in the New York City watershed. It facilitates local, state, city, and federal programs and works in partnership with municipal leaders, residents, agencies, and organizations serving the mountaintop region of Greene County. For more information, call 518-589-6871 or visit gcswcd.com.
My name is Mike Kudish. I did my doctoral dissertation on the vegetational history of the Catskill High Peaks and have been studying the Catskills ever since. I was teaching up at Paul Smith College in the Adirondacks for 34 years, and then when I retired, so to speak, I moved down here so I could continue my Catskills forest history studies full-time. As a recreational hiker before I was a grad student, I would find that some of the summits had spruce without fir, some had fir without spruce, some had spruce and fir, some had neither. Some had all hardwoods, and those had all hardwoods. Some had oak, some did not. Some had sugar maple, some did not. Some had hemlock, some did not. And I thought that was a tremendous puzzle to try to solve, because in the Adirondacks and the mountains of northern New England, the vegetation of the forests on almost all the summits of similar elevations is very similar. And in the Catskills, unless you climb to the top of a mountain, there's no way to predict what you're going to find up there. So that set me off. And it took me something like 30-some-odd years to do it. Up to about 1995, I could only go back 300 years, because that's as old as the trees were, and that's as old as the written records were. But starting in the mid-90s, I found out that I could get fossil plants out of peat and have them radiocarbon dated, and that opened up a whole new world. From 300 years, I went back 15,000. Most of the trees moved in from what is now Pennsylvania and New Jersey at the end of the Ice Age. So a lot of that early migration from 14, 13, 12, 10,000 years ago will explain a lot, but not everything. Another reason, a major reason for the forest is the effect of Native Americans and their forest fires and what they burned and what they didn't. And that would tell you whether you have an oak forest if they burned or not an oak forest if they did not burn. And then there are other factors. Tree species among themselves have relationships, just like people among themselves have relationships. They're battling it out, they're fighting it out, they're choosing their sites. It's not an obvious thing to see, but it's going on all the time in the woods. And it's how different trees relate to other trees and plants determines a lot. How much water they need, how much light, how much space. So you have a devil's kitchen, devil's path, you have a devil's tombstone, which is a huge glacial erratic boulder, and of course you have the devil's acre up on the southwest shoulder of Hunter. I think it might go back to the 18th century, not only the Dutch, but the early settlers, because of the rough terrain and all the boulders and the cliffs, and maybe they had fears of the terrain and the thick forests and the wild animals, and they thought that maybe the devil was busy in that part of the Catskills. So the cliffs on both sides are so steep and so high that you need experienced rock climbers to get up and down them with special equipment. So the hikers, in order to get up and down, use the Devil's Path, unless they're bushwhacking. And the Devil's Path was built through there in the 30s. It was built in installments. It was not built end to end at once. In fact, the most recent section of the Devil's Path over Westkill Mountain was built in the early to mid-70s, because I remember having to bushwhack up Westkill. There was no trail. You were on your own. And the campground was even earlier. The campground came in the 20s. In the 1920s, automobiles and highways became paved, more plentiful, more accessible, And people, they would bring all their gear in the car and drive up to the Catskills and camp. So you have the campgrounds, you have the hiking trails, and of course you have up on Hunter Mountain, the fire tower. That's a big tourist attraction up there. The shortest way up is the Becker Hollow Trail. And the trailhead there is where the highway is up 2,000 feet. And that will bring one up to Hunter Mountain, the shortest distance. It's quite steep. What's unusual about the Becker Trail is it follows one of Edwards' bark roads up to about the 3,000-foot level. And above that, the road ends, and then it's a foot trail.
What's a bark road, you ask? Kudish explains that in the early 19th century, hemlock bark was used in abundance for tanning leather. This early industry shaped today's Catskill forests.
The hemlocks were cut for their bark by the tanning industry. The tanning industry was a leather production industry, primarily in the Catskills for sole leather, S-O-L-E, for shoes. A lot of the Catskills leather went to Civil War military personnel. They came in about 1800, really began to get underway about 1817, 1820. After the Civil War began to decline, the last one closed, I think, about 1907. The hides were brought in primarily from Central and South America by boat, came up the Hudson estuary to ports such as Kingston and Catskill, and then were hauled in by wagons with teams of oxen and horses to the tanneries. Hemlock bark provided the tannins, which was the major ingredient in the tanneries. And some of them were very large and famous, like the New York Tannery, which is Edwards and Hunter, and the Pratt Tannery in Prattsville. The Way Tannery in Big Indian was a big one. The Simpson and the Snyder Tanneries in Phoenicia area, Woodland Valley. Some of them were very large, very famous, ran for decades. Hemlocks are cyclical. They live 250, 300 years. You get a hemlock stand that's over about 300 years old, and if it's not regenerating, it's going to die out, be replaced by hardwoods. And then maybe centuries or millennia later, hemlocks will come back in again. The whole cycle starts over again. If they barked a hemlock grove that was mature and old and beginning to die out, the chances are that hemlock grove would not be reproducing, and you'd have no hemlocks there today. Edwards built a bark road up the north side of Stony Clove Notch in the 1840s. That was the first road. And they worked both sides of the notch. That is, they built bark roads up both sides. They went up the Hunter side on the west. They barked up the east side on Plateau Mountain. In fact, if you take the Devil's Path going up from the campground, that Devil's Path hiking trail built in the 1930s follows a bark road over 3,000 feet.
Leather tanning wasn't the only forest industry in the Stony Clove. Hardwoods were cut, and bluestone was quarried.
There was a large furniture, wood products industry in the Stony Clove Valley between Edgewood and Lanesville. And this was before railroad. So the only way they could get out of there would be going down the road through Chichester and into Phoenicia in Ulster County. But there must have been a good half a dozen mills. Most of the furniture was made from hardwood: yellow birch, sugar maple, beech, black cherry, red maple. Spruce was used more for construction type buildings and such, and lumber. Spruce could also be used for other specialty items like piano sounding boards and things like that. There's an old road that goes up south of the Notch on the plateau side, and I followed it up. I assumed it was a logging road, which it had been used more recently, and of all things, it led me to a bluestone quarry. And this is south of the campground and on the east side. And I had to climb up something like 500 or 600 feet above the valley. Bluestone is a blue-colored sandstone, which was very popular in the late 19th century for building curbs, sidewalks, some buildings, and it was fairly easy to split. It was abundant. It's just in Stony Clove, I know that just one, but it was a big industry. There are other places, when you get over to Platte Clove and around Phoenicia, where there were dozens of them.
Hi, my name is Mark Whitmore. I'm a forest entomologist in the Department of Natural Resources at Cornell University, and I've been studying the hemlock woolly adelgid, its impact on the hemlock trees, and the potential for biological control of this pest, invasive non-native pest in New York and actually throughout the East Coast.
Mike Kudish spoke to us about the bark peelers, who, these men in the 1800s who were employed by the tanning industry to harvest the hemlocks and the Catskills. Today, our remaining hemlock stands face another threat, which is the woolly adelgid. So can you explain what that is and how it got here?
The hemlock woolly adelgid is a tiny aphid-like thing. It's like a teeny tiny beach ball, about a millimeter in diameter, with mouth parts that it inserts into the twig tissue of hemlock trees, not the needles, but the twigs. It's actually an interesting insect. We've identified 5 separate populations. It's native to Eastern Asia. There's 2 populations, distinct populations in China, 2 in Japan, and it turns out that the Pacific Northwest has a distinct biotype or population of the hemlock woolly adelgid that is native. So on the East Coast, the story, as far as we can figure it out, and my colleague Nathan Havel with the Forest Service has done a lot of genetic work and determined that the population that we have established on the East Coast came from southern Japan. It probably arrived in the early 1900s and as a part of a shipment of nursery stock to an arboretum in the Richmond, Virginia area. But it was first really noticed as a problem in the mid to late 50s in the Richmond, Virginia area, and alarm was raised when it got into the Blue Ridge Mountains of Virginia in the 70s. And since that time, it's moved down throughout the distribution of eastern hemlock down into Georgia and all up the eastern seaboard all the way up to Nova Scotia right now. It got into the New York area in the mid-'80s, first detected in the southern Hudson Valley, and it's been spreading not rapidly, but it's been spreading steadily in northward on the Hudson Valley and into the Catskills, southern Catskills, as well as in the western part of the state in the Finger Lakes where I live, all the way out to the Buffalo area. But it's spotty. It gets around, I think, through the movement of nursery stock, but also through wind carrying it or perhaps bird vectors. Distribution currently is primarily in the Hudson Valley where there's a lot of mortality, but in the Catskills, it's gotten into the Rondout, the Neversink area, where mortality is beginning to mount. There's some places where I've seen it infesting trees for perhaps upwards of 20 years, and that's an interesting situation. Why do some areas succumb to the infestation more rapidly than others? And I think that that's a function of site quality, where you have great soils and very healthy trees. They can sustain the impact of feeding of this insect longer than trees that are on more stressed soils. So right now in the Catskills, we're facing areas where the trees are currently dying in the south, but it's also beginning to infest areas further inland and at higher elevations. With the lighter, warmer winters, I expect to see the adelgid moving much more rapidly. And indeed, we've seen that in a couple of cases.
How do we know if the hemlocks on our properties or surrounding lands are infected by it?
The first thing you do is you go to our website, which is nyshemlockinitiative.info. And we have tons of information on there on how to identify it and what your options are when you get it on the property. But basically, it's a little tiny black beach ball with mouth parts that go into the twig. But what it produces to protect itself is a white woolly mass, hence the name hemlock woolly adelgid. And these white woolly hairs, actually it's a wax produced on the dorsal surface of the body, are very apparent beginning perhaps in December and January, because the interesting thing is this insect grows in the wintertime. It starts growing in say, October, or gradually getting larger and larger and growing through May, at which time it goes into a resting stage. And you'll say, well, what's going on with this? An insect growing in wintertime? Well, first of all, it's a great strategy if you want to avoid predation, because when are all the predators out there looking for something to eat? In the summertime, when it's warmer. The adelgid has adapted its lifestyle on the hemlock twigs, and I think you say, well, in the wintertime, it's a cold-blooded thing. How can it grow with all these cold temperatures? And you have to look at the microsite, the microclimate on the needles of the tree. And so it might not be the ambient temperature out there, which can be quite cold, but when you have sunshine hitting on those dark needles, it actually heats them up to the point that the adelgids can grow very easily. So that's one of the reasons it's been such a successful insect. The other is that they're all females. And so basically all you need is one successful female to establish, and a whole population can explode from that point.
In the regions of the world where they are naturally supposed to be, I guess, China, Japan, the Northwest, what kind of natural predators are there to keep them in check that we don't have here?
That's a really good question, and it's something that we've been considering for a long time. When we're thinking about developing management tactics for the hemlock woolly adelgid, you got to consider, what are the factors that limit population growth in the areas where they're native. When the areas where they're native, there's been an evolution over time of natural enemies and perhaps host resistance. The other thing that can impact the population would be abiotic factors like cold temperatures. We find in New York that cold temperatures do impact the populations dramatically. But the thing that's always astounded us is that the populations seem to pop right back, and much more rapidly than we would normally consider possible. And that's all related to the second generation of the adelgid. If you kill a lot of the first generation, it leaves more room for the second generation to move in and be more productive. And so the reproductive success of the second generation is enhanced by mortality in the first generation. So it's a double whammy. In the areas where the hemlock woolly adelgid is native, there actually is a very highly developed predator complex. And so I've been working primarily in the Pacific Northwest, where I grew up. And I know the areas, and I can find the adelgid. And in these areas, there are basically three predators that are the most numerous. That's a little beetle called Leucobius nigrinus, which is in the family Durodontidae. And there are two flies in the genus Leucopus, Leucopus pinniperta and Leucopus argenticalis, and they're in the Camimyidae family. And so these three predators, it's just amazing how abundant they can get with the hemlock woolly adelgid out west. And so one of the questions in our mind was, what is the impact of these predators? Is it the predation, or is it perhaps host tree resistance that we, that keep the populations of adelgids from developing into a harmful pest? And actually, I grew up out west, and I never learned about the hemlock woolly adelgid till I moved back east to work at Cornell.
Are there any biocontrols that are being used in the Catskills to control the population?
Yeah, so we've been working with the predators of the hemlock woolly adelgid from the Pacific Northwest in New York for the past 15 years, basically. We first started working with the beetle, Leucobius nigrinus. We call it Larry for short. We started releasing that in pretty low numbers. They're hard to get numbers to release. That's the real problem, and that's a whole other story. Growing bugs in the lab you'd think might be easy, but it's not. So we started releasing those 2003 repeatedly at some locations and just once at others. I think we have up to 19 locations throughout the state now. And we've been watching the growth of this predator, and it's been nowhere near as good as in the South. In North Carolina, it establishes, it spreads, and recent work shows that it's very effective at eating the first generation of the adelgid. And we are finding it had spread 30 miles from its original point of introduction. But here in New York, we've found sites where it's become established and produced 12 generations that just hasn't spread, and the populations haven't grown. In the north, where we have these temperature events that kill a large portion of the population, that actually inhibits the population growth of the predator. And so going back to the drawing board, some of my colleagues out west, Daryl Ross and Kimberly Whalen, and a graduate student, started looking at the flies, the Leucopus flies. And so I've been working with that insect, bringing foliage back and rearing out the insects in the quarantine facility here at Cornell. So we have flies to release. And we've released at a number of locations in the Catskills, in the Neversink and Rondout area, hoping we can save some of those trees that are so heavily impacted, but also in areas like the Schoharie Reservoir where the populations are just building. And we know that we have establishment of these flies. We've seen them reproduce successfully on the eastern adelgid, but we have yet to find them definitively overwintering. The big question in my mind is, are we barking up the right tree? Looking at this Leucopus, this silverfly, it actually feeds on the second generation of the adelgid. So this is the generation that takes over after that first generation. The wonderful thing is that just recently we found that indeed the pupae of the Leucopus survive our winters. So that gives us the hope that indeed this insect will survive. There's a lot of questions that need to be answered. And unfortunately, we can't go back west and collect more insects this spring. So we're sort of rather in a holding point right now. I hope that we get through this so we can get back out there again next spring and resume our work with this insect.
Is that because of the pandemic that we're facing as humans?
Yes, you got it. Human-moderated research.
So I don't have the ability to rear silver flies on a good day, but I do have a nice stand of hemlocks on my property. What can I do, or what can the average homeowner or property owner do to save the trees?
Well, that's a really good question, and one that I think really the answer needs to get out there. Basically, the biological control is not going to get out there and save the trees in the time period that is necessary, because they can succumb very rapidly to the adelgid. I can't predict when the biological control will be successful. I'm hoping that it will. And I think that, that's the long-term answer. If we can establish the biocontrol for the long term, hopefully we'll have a situation very much like where it's native in the Pacific Northwest, where we have populations that are present but are kept from being damaging by the natural enemies, by the predators. In the meantime, we're very fortunate in New York State to have tools at our disposal that will keep the trees alive for the short term. And that's the use of insecticide treatments. Now, I think it's really important that people realize this doesn't mean, getting in a big bomber and flooding the air with these toxic chemicals. That's the last thing I would ever advocate. In fact, that's why I got into the business of biological control. I was really pissed off at the use of DDT and whatever in the good old days. The use of insecticide treatments on hemlocks is actually very focused and only goes onto the hemlock trees. It's the application to the bark of the tree itself, so it doesn't even get into the soil. And it gets into the tree rapidly, takes down the adelgid population, and it allows the tree to recover, put out new foliage. And the really great thing is that with one application, we can get reduction of adelgid populations for 5 years or more. If you consider the cost over that 5 to 7 year period of time, it's actually minimal. And the investment, I think, when you're talking about trees that are hundreds of years old in many instances, the investment is well worth it.
Is there a resource for finding licensed arborists who can perform that treatment?
Yes. The first thing I would do is go to our website, nyshemlockinitiative.info, and look at the chemical treatment, the insecticide treatment section. There are lots of resources there. And, there's a lot of people that have questions about using insecticides, and I'm one of them. And so we actually have dragged up all the recent literature surrounding the efficacy as well as the environmental impacts of using these insecticides. As a part of our website, this section, we also have instructions on how to apply the insecticides. And so you can contact any arborist or applicator that's licensed to treat trees and ask them how they would do it. And if they don't tell you what you find on our website, I would question their experience and their capacity to actually pull off the job. There's a way to do it. There's a way to do it right. And if you contact somebody and they don't know how to do it right, don't hire them.
Can you just talk about the importance of hemlocks in general in this region and what the Catskills would be like if we didn't have them?
Oh, geez, I can't imagine what the Catskills would be like without the hemlocks. Really, I've been doing this for 40 years, and one of the most common reactions is like, oh, my goodness, you mean they're gone now? What's that old song? You just don't know what you got until it's gone. And it really is true. The decline of the hemlocks is gradual. It isn't dramatic. But once they're gone, all of a sudden you realize that things have changed. Hemlocks are known ecologically as a foundation species, which basically translates to they basically provide an environment which is essential for the survival of a number of animals, plants, whatever, that depend on them to provide that habitat. And consider it this way. If you have an ash tree, which is topical these days, and all the ash trees in your hardwood forest die, what do you have left? Functionally, a hardwood forest. Whereas if you have a hemlock forest and all the hemlocks die, what do you have? Well, you have a situation where you're going to have a hardwood forest. The hemlocks are gone, and the whole game's going to change. This is really important, I think, in the Catskills and in the Adirondacks as well, where hemlocks are an important part of the forest, and they sort of like form islands for these other species to survive in. And I don't know, there's just something about hemlocks in my mind that pulls at my heartstrings. I like to think of them as the Labrador puppy dog of the tree world. There's just something about it. I can't describe it, but I love those trees.
Considering all the data and all the research you've been doing throughout your career, are you more optimistic or pessimistic about the future of hemlocks in the Catskills?
Oh, that's a really good question. Because this can be a really depressing profession. When you think about it, look at all the ash trees that are dying now. It's like, I can't believe what's happening with these invasive species that are just changing the face of the earth. And I've been doing this a long time, and I really, it's like if I got depressed, I would, crawl up in a ball and not do anything. And I've gotten over that. I do have hope. If you don't have hope, what do you have? And so that's what drives me, the hope that someday we will be successful. And I've seen that recently. It was an amazing event to find that indeed the silverflies can overwinter. That was something that we've been looking for a number of years now. And so it gives me hope that the silverflies, in combination with our Arcobius, for the long term, they will help save the trees. But in the short term, I think we really need to be responsible about maintaining the hemlock resource that we have in place. And there's many parks and areas where actually the trees have been treated, like at Minnewaska State Park and a number of the state parks out here in the Finger Lakes area as well, where basically if we hadn't treated those trees, they'd be dead right now. And the aesthetic nature of these parks, they would be forever changed. And so I'm really glad that the state has stepped up and is really taking the hemlock resource seriously and keeping it alive, hopefully until we can really implement the biological control for the long term.
Original music by Josh Roy Brown. Catscast is a production of Silver Hollow Audio. Please don't forget to subscribe, and we'll see you again in 2 weeks. Thanks to our sponsor, the Greene County Watershed Assistance Program, and the Catskill Mountains Scenic Byway. In this restrictive time, consider supporting your local restaurants and cafes by buying gift cards for future use, either for yourself or as a gift. Many eateries are offering online ordering with pickup at the door. Use the web to visit our hospitality businesses along the Catskill Mountains Scenic Byway and discover special deals for future visits. Make a contribution to your local food pantry to help those volunteers provide food for those in need or who simply can't get out on their own. Most are delivering food, so consider volunteering as a driver. And our wine and spirit shops are open with very specific order and pickup requirements. Give them a call. At the moment, our theater, exhibit spaces, and arts centers are taking a back seat and focused on planning for later in the season. Make a contribution to be sure that doors open again with all the cultural programs our communities enjoy. Thank you.